Before we get into the details, it's just some general concepts of describing data. In general, in order to be able to describe data at all, we need some sort of data model, which is a collection of concepts for describing data. Data models have schemas, which are descriptions of some particular collection of data expressed in that given data model. So given a data model, you can get a schema for your particular collection of data. We've been mostly focused in this class on the relational model of data, although we did spend some time also on an information retrieval model of textual data. But in the relational model of data, the main concept obviously is the relation, or the table, which has rows and columns. Every relation has a schema which describes the columns. It includes the names of the columns, the domains or types of the columns, and the order in which the columns should appear. An important aspect of the relational model is that it allows us to have three levels of abstraction that can be used to introduce important separations of concerns. At the highest level, we have what users actually see. And by users, I mean both end-user querying and also programs that connect to the database. These programs are given access to views over the data, which are, as you know, named queries of the data. And those views can represent subsets or aggregations of the data in the database. So the cow might see one view of the data, where the puppy sees a second view, and the little child sees a third view. And each of these views might be different derived views over the same base data. Underneath that, there's a conceptual schema that's global to the database that tells us what are the relationships and the attributes of those relations in the database. And this defines the logical structure of the information that we're actually capturing and storing. And then finally, below that, there's a physical schema that describes the files and the indexes that are used to represent the data in the logical schema. And this includes both, what columns have B trees on them, and also how are you partitioning your data across multiple disks. So all the details of data layout and data organization and data structures are part of the physical schema. So as a concrete example, we might look at this university database. The conceptual schema is just three tables: students, courses, and enrolled. The physical schema might be that the relations are all stored as unordered files, as heap files, and there's a B tree index on the first column of students, SID. Meanwhile, we might have an external schema, a view, of course info, which only has two columns, the course ID and the total enrollment per course. And that view is generated by a group by query over the underlying enrolled table, but someone who sees that external schema can't actually see who is enrolled in what course. They can only see the number of students enrolled in each course. So these views can allow us to hide information in the database in ways that involve even computation. They involve queries that compute over the data. So we can expose whatever views we like to the user, and we can hide whatever tables and views we like from the user.